All right. Hello, everyone. Thanks for joining this workshop of Introduction to MATLAB. I'm the instructor. You can call me In. And so a couple of announcements before this workshop. So this workshop is targeted for people that know nothing about code, know nothing about MATLAB. And so the style of this workshop will be to introduce very basic MATLAB coding, and we will code step by step. We will have some practice in the workshop, a lot of examples that you will have chance to code by yourself on your computer. And then the second is that for those students registered to the 275, maybe this time there will be a different code for this course. It's 197 or something. If you are registered to this class, then you need to attend all the 3 days of this workshop. And the third thing is that room link, it's equivalent to a signature form. So if you want to sign to indicate you to join this workshop, you can just stay here, and the manager will just count how many people participating in this Zoom as your signature. And the last thing is we will have a quiz at the beginning. It's very easy. It's just to help you get a brief idea on what we'll taught in this workshop. And in the end, there will be another quiz. So that quiz will include the quiz we did in the beginning and a few more questions, right? So the quiz at the beginning will also be redone by you in the end of the course. So the goal of this quiz is not to just to help you help you get more familiar with what we taught, and it's not for really test you. It's not difficult. So feel easy about the quiz. Just try your best. And also for those students who register to the course, we will have a final homework, which will roughly take 2 or 3 hours for you to code. And if you want to get credit, you need to do this homework. I will give probably 2 weeks after this workshop, and please head in before the deadline, 2 weeks after this workshop, and I will give you a score based on your homework. So the last thing is we will record the whole workshop. Okay, if there is any question, we will begin to the real part of this workshop. So let me start with introducing MATLAB. So MATLAB is a very convenient software to code, and it has some properties. For example, it has graphic interface, so make it very friendly to use. And its coding environment is relaxed, and its basic manipulation is in the matrix form. So most of the time we code in MATLAB we are dealing with matrix. So we will spend a lot of time on learning how to deal with matrix. And it also has a good function of plotting. So you can have plot very beautiful figures for your visualization. And it also has a good documentation. So this documentation, either MATLAB software itself has built-in documentation, or you can also Google online any function you want to realize by MATLAB. And it can interface with other languages like Python, like R. So there is a code that you can use to use some Python code in MATLAB, or the other way around. And so it can interact with other code, so which make it even more convenient because nowadays many people are also using Python or R. So sometimes you might have one package from MATLAB, another from Python, and then you can put them together. Okay, so this 3 days workshop will cover the basic of MATLAB. So this is the outline. Just take a few moments to briefly read this outline. So you don't need to know what exactly for each of this term we will go through, but just get an impression of what we would teach in these 3 days. So day one will basically be the very operations, either operations on the MATLAB interface and start to write script. And then day two will introduce a bit more complex data structures and introduce functions. And day three will be in plotting. So the hardest part, I would say, is day two. Day two because we will need to deal with function. So the function, how do we write a function and how do we use function? Once you know that, I guess it's that you can learn any code of MATLAB by yourself after that. So so the difficult part is day two, and then day three will be getting easier to do some plotting, and at the end we will have some introduction on some real example of using MATLAB to analyze some real data. Okay, let us begin with a small quiz. So to do this, could you open the quiz link I sent to you in the email before today? I sent to you an email yesterday. I guess most of you should receive it. If you don't receive it, let me pull up that link to you here. If you have the link, please open the link and spend 5 minutes to do the quiz. Try your best. Don't be afraid if you don't know what does that mean, but just try to get an impression of what we will teach. 5 minutes. Thanks for sharing the link. For those who just joined the Zoom, we are doing a quiz. And the link for the quiz is in the email and also in this chat room. Please take 5 minutes to do the quiz. Okay, I got 6 or 7 response. So if you haven't finished, you can submit soon, and I can go through this quiz with you together. So I saw most of you get probably 3, 4 points. I got 9 response now, 8. So which means that many of you can get the correct answer for 3 or 4 questions. It's okay because I haven't told anything, so it's a bit difficult for you to get the correct answer for some of them. It's okay. So let's go it together just to get to help you figure out some question to give you some first impression. So first question is, do we need to align each code in MATLAB? And the answer is no, because MATLAB has a relaxed code environment. So the second question is, what about in Python? The answer is yes. So if you have an experience in Python that you need to align each line of code in a certain way in Python, but in MATLAB it doesn't require to do that. So what is the starting index of an array in MATLAB? Starting index means what is the index for the first element in an array? And the answer is 1. So if you this question is also to compare with Python. So if you know Python, Python starting index will be 0. MATLAB is always starting from 1. And next question is, what is A? Right, so you say A is a middle bracket. Say middle bracket, and then 1, 2, 3 separated by comma and semicolon, and 2, 4, 6 separated by comma. Right, so pay attention to this semicolon here. And once you have semicolon, it means switch line. Switch line. So it will from line 1 to line 2. But instead, if you have comma, it doesn't switch line. It's just to separate the different number or element, right? So this one will be a 2-line data structure because it has a semicolon here. So it's 2 line and 3 column. So it's 2 times 3 dimensional data structure. And when you have a middle bracket, it means matrix. It means matrix. So we will have pay a lot of attention on the small bracket and mid bracket and the big bracket. Right? So this different bracket means different things in MATLAB. So in the end, what we will have is a 2 times 3 matrix. It's not a vector. It's not a cell. So we will teach what is cell. So cell is a different data structure. So next question is, which one is correct to define A as a 3 times 2 dimensional matrix with elements 0? 3 times 2 dimensional matrix means you need to have 3, 2. And the difficult part here is zeros is a function in MATLAB. It's a built-in function. And remember that whenever we use a function, we use small bracket to give it some argument, small bracket. This with middle bracket or big bracket is simply wrong for function. If you type this in MATLAB, then it will give you some error. Right? Whenever you call function, zeros is a function, and then you need to use small bracket. And 3 times 2 is just 32. And here you also see ones. Ones it means all the elements to be 1. And so zeros and ones, different functions. And which one is correct to define A as a 3 times 2-dimensional cell? So we just mentioned that cell is a different structure, data structure. And when you initialize this data, you can call a function called cell. So cell here again is a function. And remember that when you have a function, you use small bracket to put the argument. So therefore, it's small bracket. And so therefore, B, C, D are run code. And 3 times 2 is just a 3 times 2-dimensional cell. So this should be the correct answer. Let's see, yeah, so this is the correct answer. Any questions for this quiz? Okay, if not, we can go on. Okay, let's start with introducing MATLAB. Have everyone got MATLAB installed on computer? If not, please report. Great, thanks. Great, so if you have MATLAB installed, then, sorry, I got another chant. Great, yes. So if you have it installed, then please open it. Open the MATLAB, and then you will see an interface mostly like this, right? Maybe not exactly the same, but the schematic is the same. And so here you can see that on the top, there is in the red box here, there is a search documentation. Here is just like a Google search, but it's not Google, it's just a search the built-in documentation in MATLAB. You can search some function. For example, you can search zeros. You can try zeros and see what it gives to you. It should be a documentation on the function, right? So whenever you need some function, just search. And there are also many buttons on the top, right? So you don't need to know what every button is used for, but many here, you see that there is home. In the home panel, there is some choice you can play with. And most of the time, we will in the panel editor. Editor means you can do some editing on the script. And there is a run button, means you want to run the script, run a current script. And so we will go there later, but just to briefly introduce here. But other buttons you don't need to mind if you don't know what it is. It's just like a phone. When you first time get a phone, you just need to play with it, and after a few days, you know what each button means. Okay, then on the left side there is a window called current folder. So this one is important because it shows what the folder you currently in. Right? So MATLAB cares about your path, your folder path you are currently in. It can only load the data in your current folder if you don't specify where the data it is, right? So here you see in my folder, this folder, I have different files. I have Excel file. I have here .mat is a MATLAB file. It's a MATLAB data file. So if I have this MATLAB data file in this folder, I can load it. If it's not in this folder, I can not load it. So all this. Also, if you want to save some file, later we will save file, it will be by default be saved in this current folder. Right, so MATLAB will just show which folder you are in, and everything you did will be recorded in this folder. And on the right is window called workspace. So this workspace means what data, what variables we have in current running. Right? So it's like saved some data variable in the memory of our computer. It's temporarily saved in MATLAB. Right? Currently, you see here it's empty. So it means nothing was implemented or saved in MATLAB. And in the medium, there is a window called editor. So editor simply means to editing the script. So you see I have several files open here. Open system 1.m. So .m is a MATLAB script. Right? So I also have an untitled script. So this script is it's just like some paper, then you can write down some script. And after you write down the script, you can click run on the top to run this script. You can open several scripts in this editor window, and by clicking them, you can go to different script. Okay, and then last, in the bottom, there is a window called command window. Command window is our interface. You can type any short code into this command window and click enter, and then it will run this line of code. You give to the command window. So command window is like a short version of script. So it's more fast to interface with, to interact with the user. So for example, you can try to type anything in this command window and click enter to see what it gives to you. Okay, so here is some attempt. You can please try to type in these things in your command window, right? So you see this double arrow here. You see 2 plus 2, please type 2 plus 2 and enter to see what it gives to you. And also this is 3 hat 2 sine pi over 2. Right, please try in your MATLAB command window just to get familiar with MATLAB basic usage. Okay, so I have, I'm currently sharing the screen of my MATLAB here. You see all the things we just mentioned. Right? So I'm currently in the folder, so which we will introduce later. It's a files for you to later to code. So I have several script open, but it's for my own project. Don't mind the script here. And we go to the command window here. We can type anything, right? 2 plus 2, and give you some answer. ANS. ANS here means answer, but it's a short version of answer. So answer is 4. And note that here now we have this variable ANS in the workspace. Right. So workspace will save this variable ANS and its value. So now you can try other things. And now the ANS will be equal to 9. So now you see that the variable in the workspace has been updated by the new operation 9. And now you can type ANS. So once you have the variable saved in your workspace, you can call this variable, or you can maybe just use that variable by typing its name. So we have a variable ANS, you can type ANS, then it will just give you the value of this variable ANS equal to 9. If you type other thing, like AN, but it doesn't have a variable in the workspace, then it will give you some error. It says undefined functional variable. Right? So if you want to call variable, use a variable, make sure you have it in the workspace. Otherwise, you need to define this variable before you use it. Right? Like here, we just type anything and then you save the ANS, then ANS is defined. So therefore, in the end, we can call this variable. You can also try other things. This will give you infinity. INF means infinity. You can also try to use some scientific notation of the number. 1e plus 04 means 10 to the power of 4. 1e plus means 10 to the power. So these two number times together is 10 to the power of 10. And you can do any arithmetic operations in the command window by using these operators. Exponential is hat, division is the slash. And I have just introduced that you need to remember that whenever you want to call variable, it should be saved in the workspace. And another thing we need to pay attention is a semicolon used in MATLAB. So let me go to MATLAB to introduce this one. So just now when we type these operations, right? So we don't have any semicolon. And therefore, whenever you type any operation, it will show you that ANS equal to 4. So if you have a semicolon here, right, in the end, semicolon, when you press enter, it will not show anything, right? It will not show the ANS value. So whenever you have semicolon, it just didn't show anything because it recognizes that this sentence, this line of code is terminated by having semicolon. It's terminated, doesn't show anything. If you do not have semicolon, it will show, okay, I run this line and just show what line will give. So then it will be ANS, show the answer, right? But instead, but still, when you have the semicolon, right? Let's say we have different expression and semicolon. It does not show ANS, but the ANS variable will still be updated. Right? When I try this, it doesn't show anything. But you see that in the workspace, ANS has been updated to be 9, right? To be the new operation I did. Right? So it's just with semicolon, it just didn't show the result, but it was already implemented and saved. Oh, sorry. And then let's go back. And another thing in MATLAB is a comment, which is percentage symbol. And whenever you have a percentage symbol here, the rest of the line will be commented. So it does not have any function in doing something. So you can write any comment. So this is useful when you want to make some notes to say what this line of code is doing to help the users of your code. And this is variables. Just we mentioned that you can define variables, right? So if you don't give it any variable name, like the 3 had to here, it will by default save to variable AS. If you want to define a variable, you need to have it name and equal to something. X, Y, Z equal to something. You can try this in your command window. Try this and see what it gives you in the workspace. If you have a try, you'll see that these variables will be saved in workspace. And with a semicolon here, it would not show anything, right? But the variables will still be defined and be saved in workspace. And you can also try input I here. So I will be the imaginary number. So it's just the imaginary number, I squared equal to -1. So let's say if x equal to I, x equal to I will have an imaginary number, right? So it's 0 plus 1i. And if I type rel x, so this one is rel will be a function, and x is just its argument, its input. So this function will return the value of the rel part of this variable, which should be 0. Right? So it's 0 because its rel part is 0. If you type imaginary imag, then it's 1 because its imaginary part is 1. Right? So whenever you have a variable, now then you can input the variable into other functions, which load the number as a function as an input. Those functions can load this number and return some values. All right, so this is just an example of using coin function to get to the real and imaginary part of a number. And so now then you can basically do any operations on the real number, imaginary numbers, plus, minus, all these basic arithmetic operations you can do. And the second note is that variable are case sensitive, right? Lowercase x and uppercase x are different. If you do this and you type capital X, you will see it's undefined. And consequently, MATLAB gets now, these years get more smart. And it will say, did you mean lowercase x? It will automatically ask you this because it may infer that you might make the case sensitive wrong. And it will ask you whether it's lowercase. And sometimes MATLAB will ask you if it finds some similar string in the verb in the workspace. And we have actually have introduced that if you didn't specify the variable name, by default it will be saved to a variable called ANS. If you specify it, it will give to the variable name you want to define. And to look at what's saved in the workspace, you can type who, enter, and then it will show what variables are in the workspace. You can type who, try in the command window, and compare the result with the variables in your workspace. And you can also type whos, I can type whos, where it will show all the variables and their information. It's basically what I can check by looking at the workspace. If you want to clear a variable, you want to delete a variable, MATLAB has a code called clear. Clear, if you want to delete certain variable, you just give it a name, x. Then x will be removed. When you say x is removed. So then if you type whos again, you will just show the NS variable. And so clear is just to remove a variable. But type clear alone, you will remove all the variable. And so this will remove all the workspace. This one is useful because later if you have some complex code that you will save a lot of variables in your workspace, these variables will take up your memory of the computer. Right? So at some point you want to free up this memory by deleting all the variables. Then you simply use clear. So typically when you read some script, you have clear in the beginning. You see here, I have my script. I have a code called clear. It will clear all the variable in the workspace. In case that some variables will alter my code below. And so if I have some code below, maybe I have some similar variable name used in my code, and I don't want to load the previous old variables by some other script in case there's some confusion or mixed use. So therefore I have a clear to clean up the workspace. And similarly, we have close or. Close means close figures. When you have figures, you want to close the figures, use close. And COC means clear command window. You can try COC. COC, and everything in the command window was cleaned. So that's exactly what I have in this script I have here. Now, clean the command window, I have a clear workspace, and close all the figures. So remember this three, which is very useful in any time in your coding. Okay, now if you have something in the workspace, next thing is you want to save this one, right? Save as at the end of the day, you did a lot of coding and you have some result in the workspace of your data, of your variables. And then you want to save this file. And then next day, tomorrow, you want to reload this data. So to save this file, you can type save and give the file name, my file. Right? You can try this and close MATLAB and then reopen it. Right? And then load the file you just saved, but type load this file. Right? Try this, please try this. Save the variables in your workspace into a file name, close MATLAB, reopen, and reload the file you saved. Please try this, and we'll have a break. We'll have 5 minutes break. You can try this. After that, feel free to take a break. Or if you have any question in the meantime, just you can type in the chat room. So see you in 5 minutes. Okay, any question? Have you successfully load the file? Great. Thanks for your response. Okay, I guess it's let's try this. I type anything I want. I have something in the workspace. I can save any file name. You can give a file. And then if I type this, then you will say that here in the current folder, everything in the workspace will be saved into this file. To load it, so then I can close MATLAB or reopen. But I reopen, I need to go get into the current folder. So here I just do not do that. But so let's assume now we reopen the MATLAB and get into the folder, and we want to load this file, right? So here I just clear everything. Now I have nothing in the workspace, nothing in the command window. So it's like reopen. And then I can load this file, right? So you can type load this file name. I can also load up my other files once in the current folder. I have another file, F1 here in my folder. I can load F1. You see that some variables will be loaded in the workspace. You can also double click the files here to load the file. Once you double click, you see that it's load this file. So then it will load other files. So notice that when you load other files, it will just load it will not cover the previous file. Right? So the previous variables will still be in the workspace. Right? So it's like an additive way of loading the file. Okay, then if no question, we go to the script. So this is what we introduce is basically command window. So you can do any arithmetic operation and load file, save file in the command window. Right? So which is easy. Each time you just type one line of code. So if we want to have multiple lines of code, a bit more complex code, then we need to write a script. So when you write a script, the first thing is to open a script. Right? So you can go to MATLAB and go to the home panel and click the new script, or you can type edit in the workspace, or edit some file name of the script you want to give. .m. So .m is a MATLAB script file. .mmat is a MATLAB data file. And then once you open script, you see that you are in the current script, right? So we can have a script, and you can type anything in the script. So here I have, sorry, I got a question here. What's the difference between normal script and a live script? Could you explain, hey David, could you explain what they mean by normal and live? Hey David, if you don't mind, you can unmute yourself and just explain what is normal and live. Hey, David, I can't hear you. Do you mind to explain your question? Okay, if you want to explain your question, you can also type in the chat room. Because okay. So I try to understand your question. What is the normal script and the live script? By normal, do you mean the script were opened or? Oh, okay. Actually, I don't know the live script because I haven't used live script. So I guess the format is a bit different. I guess you can type a different code, different things in the live script. I personally haven't used live script, but my guess is you can type not only code, but maybe you can also insert figure, some other things in the live script. So it's definitely a more advanced script. Yeah, so, but I haven't used it by myself. Okay, another question is what's the difference between type load my file and typing edit my file? Okay, good question. Load my file means to load the MATLAB data file. Right, so it's load my file. This load my file means to load this data file. My file. So it's load the my file dot mat. This is a data file. And you see here, I load the file into the workspace. So edit my file. This will be to open a script. So it actually means edit my file dot m. Dot m is a script file. So if I type this, it will say whether I want to create a script. Right? So I have the same script and then a script with the same name in my current folder. So let's try another name, my file2. Then does not exist. So it will create a new script here. Right? So it will create a script, but load file simply means load mat file. So it's not a script, it's a data file. So that's a difference. So now, once you have the file, you can, once you open the script, you can type any code here, and then you can run the script, run this script. And so everything we did before in the command window can be right in the script in a composed way. So you can, so basically it's just compose several lines of code you wrote in the command window, and then line into multiple lines, and then you can run this code all together. So for example, here I have defined these variables, gene, expression 1, 2, 3, calculate their total gene expression, their average, and finally I type DISP, which is a short notation of display, and display this variable, average genes. So once you have this in your script, you run this whole script, it will give you the average expression of this, right? And so it's just a composed way of running multiple lines of code. And so displays here is the same thing as printing in Python. So it's the same but different use. It's display. So now we can go to some example script. If you have downloaded the script file, please go to the day one student folder I shared to you. It's a zip file. When you download it, please unzip it first. And when you unzip, you will have a folder. Get into that folder, day one student, and open the script example one. Right, so here I have already getting to the folder. Right, so you see the folder is day one student here. And I can open this script by double click. You see here. So now here is a task for you. Please run this script and write a few code, a line of code to save the variables into a file name called irf cax irf says. So to add a line of code to save the result into a MATLAB file. After you add the code, just click run, and it should save the variable into a MATLAB file. Please take a minute to finish this task. Questions? If not, I can try here. Okay, so I need to add a code to save the file. So it's either here, save irf cax. You can also add the mat. So then we run this code. It shows example one, means I run this script and I'll do the calculation. Right, and then I will save all the variables in the workspace. So I also have a variable xy because that's generated previously, right? So to avoid this case, to avoid save some unnecessary variables, you can add clear at the beginning. So you can try to run again, and then you say there is no xy because I clear everything before I run the following. And then I will define the variable name, do the calculation, and save all the variables into a file. Right? So you can see that I have a file saved here. So that's the first. Now you can open the example 2. Right, so this one is the following task. Just load the file we have just saved and do the further calculation. Right, it has a calculation, just say what it gives to you. Take a minute to try this. So here is also simple, right? So you just load the file we just saved, load this file. Just copy the name here, or you can also .mat, right? So it's the same. And after you load the file, it will give you a calculation because the files you saved have the variable, these two variables. You can now use these two variables to do the calculation and give the value to a new defined variable. It's called IRF induction. Oh, by the way, so IRF is a gene. If you don't have biological background, IRF is a gene. It's an immune response gene. So we just calculate the induction value of this gene given its stimulative value and the naive value. So this example, two examples, just it's simple. It's just we have done save file and load file, but in the script. So now you can open the example 3. You can run this script. Right. So the example 3 is to show you that the number has different format. You can change the format of manipulating the numbers. So the task is here. I want to set the format back to the default format. Add a line of code to reach this task. Please do this in your computer. Okay, we can do this together here. Example 3. So when first is I can clean up everything. Right? Clear the command window and workspace. And I run this code. I see I have several output. Right? So it's basically the first op x equal to pi, and then I change the format. It has different format. Don't mind if you don't know what is the format. It's just non-short, back, rational, different format of this number, right? And then remember here, I do not have semicolon after I define x, so it will show what is x, right? It will show like the first line, it will show x equal to the pi, the value of pi, right? So pi is just the value of pi. It's just the number, the pi. And then I change the format of this number output. I show the pi again. So now you see that pi has a longer precision. Right? So it's after I change it to long, and after I change it to short and other format, right? It's just a change the format of showing the number. So now the question is, how do I change back? Because in the end, I have my x equal to a rational number, right? So in the end, the last line of my code, x equal to pi will give a rational number. So how do I change back to the default? So now the default is the first one, right? So it's 0.1416. How do I change back? You just say that which format gives you this number of default. Right? So it's short. Right? So it's short. Format short give you the default is the default. So now I just add the format short before the last output. Right? So now you run the code again, you see that the final output is the default 3.1416. Right? So this is just to give you a sense of what the default number in MATLAB is and how do you change the format. So sometimes you need this because in terms of specific tasks, you want to keep different precision of the number of the output. So you need to change this. But most of the time, default is enough. Default number precision is enough. So short is the default, and you just change back. Okay, so now we get into a bit more complex data structure. It's a big picture. So we just deal with numbers, right? So it's number is just a 1 times 1 dimensional vector. And so, but other times, most of the time, what we would do is to deal with the matrix and the vector. So we will have therefore we need to be very familiar with how to handle vector. So the first thing is how to define vector. So here I have some example of define a row vector. Please type in this row vector equal to 1, middle bracket 1, 2, 3, 4, 5, and these things below here. Just type these things, try in your command window, and see what you get. So this is important because it will help you familiar with how to define the vector. And please try this in your command window. So here, a middle bracket, actually we did this in the quiz, right? Middle bracket means to define a vector. It's like a collection of numbers and write the numbers into a vector. And comma is just to separate the numbers without changing the row. Right? So it's one row, 5 elements. So it's 1 times 5 dimensional vector, right? Or 1 times 5 dimensional matrix. Right? So 1 times 5 matrix is a 1 times 5 vector. So it's a row vector, 1, 2, 3, 4, 5. You can define it alternatively by having the code here. So 1 code 5 is 1, 2, 5 with step size 1. Right? So its default step size is 1. So it will automatically give you 1, 2, 3, 4, 5. So alternatively, you can try to do this. Row vector equal to middle bracket 5 code 1. Please try this in the command window. Great. I see some of you got 1 times 0 empty vector. That is a correct answer. The reason is that code has a default step length 1. And imagine that from 5 to 1 with step length 1, what is the number? So there's no number then, right? Because 5, next one is 6. You will never go to 1, right? So it's an empty vector. It gives you empty vector. But if you do this, it will give you empty, right? So 1 times empty vector. So how do you define a vector that from 5, 4, 3, 2, 1, right? So then you need to specify step length. How to specify is you add a middle number here with code, 1 code, and -1 code 1. So the middle number here is the step length. You basically change the step length from default 1 to -1. Right? So it's 5 -1, which is 4, and 3 to 1. Now this way, right? This way you will get the vector, right? So just remember that first you have an easy way to define a vector with code. Code will give you a consecutive step length vector between 2 values, but the default step length is 1. If you want to change the step length, you need to use 2 code. And after you define a vector, you can check the size of the vector by using a function called size. Size is just a function. Right? So whenever you use a function, you use a small bracket instead of the middle bracket. Middle bracket is to input numbers, specific numbers. Small bracket is to input argument for a function. Right? This argument can also be a number, can be a variable, but whenever you use this function and give function an argument, then you should use small bracket. So size function will return the value of the dimension of this vector or matrix, right? Whenever you use size. Size AS, right? So you see the AS, I have the AS value here. Now if we return its size, it's 1 times 5 dimensional matrix. And you can also try size AS1. So this 1 here is to return the first dimension of that matrix. It's basically the number of rows. And if second, it's number of column. Okay. So now I can try the size in S2. What do I get? I will get the column number of that matrix. Right. So you see the answer is 2. Right. But I type of 1 times 5 dimension vector. So why the answer is 2 here? Anyone volunteer to answer this question? If you have answer, you can unmute.
Professor?
Hey, hi.
It gives 2 because is it giving the second value in the vector?
Could you say again? It's give a second value.
So it gives 2 because it gives the second value in the vector, which would be 2.
But the second value in the vector is 4, right? So my vector here is 5, 4, 3, 2, 1. Right? Yeah, but good try. It's if I give a vector 1, 2, 3, 4, 5, then you might guess that its second value is 2. Yeah, thanks for the try. And I also say another answer that by Miko that it says that ANS was redefined in the previous slide. Yes, that is the correct answer because ANS is redefined here. So here I first type a vector, right? I type this one. It will be saved into a variable ANS because I didn't name it. It just saved in default variable called ANS. So now ANS is this vector. Now I type size ANS. So you return the size of this vector. It's 1 times 5, right? Correct. That's should be. But after I do this, it's automatically saved into an ANS variable. So ANS is now covered by the new result. Now ANS changed from this vector to 1, 5. So now this is a new vector, right? So it's 1 times 2-dimensional vector. So now if you use size function, size ANS2, it's return the dimension of ANS, which is 2. If you try this again, you say that it would be 1, right? Because ANS now is a 1 times 1-dimensional vector. It's a single value. Right, so this is a little bit tricky because if you do not define the variable name, it will automatically save into ANS and will be continuously covered. Right? Sometimes this will cause some tricky bug in some code because you don't name the output, it will be automatically saved into ANS, but you did it multiple times, and only the last time value was the final ANS, but maybe you forget it forget some forget where you did to lastly save the ANS, and then cause some bug in the code. So again, numbers are 1 times 1 matrix, and the array of the number start from 1 instead of 0. So all these operations in numbers apply to vectors. And so if you have 2 row vectors, same dimension, you can add the vector. Right, I have a row vector, I have second vector, add them up, I get element wise add, right? So it's all the element will be 5. So now the key point is that whenever you do the operation to vector or matrix, you need to pay attention to its dimension, right? So if I add 2 vectors whose dimension does not match, then it's wrong. So it cannot be done. It will give you some error. Right? So if I try this, I add a row vector and to a column vector. So now here, when I define column vector, I also use a middle bracket, but I use the semicolon. Right? Semicolon means switch row. So every element has switch row, so it will give me a column vector. Now I add the row vector and the column vector. By linear algebra, this operation doesn't work. Right? So you will get error. But actually, if you try this in the new version of MATLAB, it will probably give you a matrix. So MATLAB in the new version, it has maybe my version works. Let's try 1, 2, 3. Let's say. Right. So if MATLAB in the new version, it will have some weird operation by adding a row vector and a column vector. Right. It will give you a matrix. So this was probably updated in the new version of MATLAB. But in the standard linear algebra, this is wrong. Right. So this doesn't work. because the matrix dimension does not agree. Right, so this also works for the matrix. Now we can define matrix. This is a 2 times 3 dimensional matrix. If their dimension matches, I can add them up. Now comes the tricky part. It's when you do a manipulation of a matrix, it times 2 matrix, there is a difference between the star and dot star, right? So this one is a little bit tricky. Let me explain it in a note. Because this one is, in my view, it's simple. It's not difficult, but it is the most tricky part in this workshop, because from my previous experience that most of the students will after this workshop they will still make it run like in the quiz. Right? They still do not fully understand or fully remember what's going on for this matrix product. So let me start by review the linear algebra. So linear algebra, what is matrix product? Right. So if you do a matrix product to this matrix and that matrix, what do you get? Right. So if you remember the rule of matrix product, you will get the answer like the lower left matrix. Right. So it's the first row times the first column to be the first element, right? Lowercase a, capital A, plus lowercase b, capital C, right? First row times first column. Second element is first row times the second column, and so on. So the other elements will obey this rule, right? So the nth element and mth column in the result will be the nth rows times the mth rows times nth column of the first and two matrix. So this is a matrix product. If you don't remember this from linear algebra, please Google it or go to wiki to recap this one, because most of the time it's easy. I know it's not difficult probably for many of you, but from my experience, most students will get this wrong, not because they don't know how to code, but because they don't know how to do linear algebra of matrix product. So this is a matrix product. So when you do matrix product, the key is to keep the column dimension of the first matrix to match with the row dimension of the second matrix. Right. Once this dimension match, you can do the matrix product. For example, the first matrix A, B, C, D here, I can even add more rows, right? I can add EF, many rows to be a very high matrix, right? So very high matrix. But if once it has only 2 columns, it can be product with the second matrix here, right? I only need its column number to match with the second matrix row number. Right, so that's a matrix product. So alternatively, in MATLAB, we also use it quite often is the dot matrix product. It's dot star, which will give you an element-wise product. Right, so it will be the first element times the first element, second times second, right? So this is the element-wise. So please remember the star is standard matrix product. Dot star is the element-wise product. And consequently, when you do the element-wise product, the two matrices need have exactly the same dimension because it's element-wise. Otherwise, the operation is invalid. So this is a very tricky part. So maybe you can, you understand, you remember it now, but if you don't truly understand it, you might forget after some time, right? So it's easy to make mistake. Even for me, sometimes when I code, I have many years of experience. Sometimes the code, if I'm careless, then I may make this wrong when some part of my code. So now here, you can try this, right? So if you have typed this two matrix in the command window, you can try this star, right? So please try this. Try type two matrix and do the matrix product by using star. But also do the element-wise product by dot star. I tried this too for matrix. So if you finish this, you can also try to change a different dimension of matrix, right? Change the two dimension of the two matrix and play with star and the dot star. Take 2 minutes to play with it. Any question for this matrix product? Okay, I got a question. So please feel free to ask a question here, because this one looks simple, right? But it's in the end, in the final quiz, there is some problem regarding to this point. 17 or 18 students didn't make it right in the end from the previous experience. So it's very tricky here. I have a matrix AS here. Let me give a matrix. First matrix, just same matrix. I have two matrix, B, C, which are 3 times 3 matrix, right? If I do B star C, I will get a matrix product, right? You see the number. It's the first row times the first column to be the first element. If I have the dot star, it will be element-wise, because the dimension of these two matrices exactly matches. So now if I have A, right? So A is a 1 times 3 dimensional matrix. If I do A times B, right? So B is a 3 times, let's say what is B? B is a 3 times 3 matrix. A is a 1 times 3 vector. If I do 1 times B, this doesn't work, right? Because the the dimension doesn't match to do the matrix product. So now, but if I do the reverse, do the inverse, B times A, this will work because the dimension just matches with the matrix product, right? So 3 times 3 matrix times 3 times 1 matrix will be a 3 times 1 matrix, right? So this will just the matrix dimension will match, right? So remember that if M times N times N dimension matrix product N times L dimensional matrix, it will be equal to M times L dimensional matrix, right? So this 2 number of dimension will just be concentrated. So that is a linear algebra. Okay, so now we can handle the vectoral matrix. Please go to example 4 and try to revise that code. This one is what we just told, right? So it's just you need to change the matrix product to be an element-wise product. So the only thing you need to do is to add the dot star. Then it will do element-wise. So the answer is here. You do element-wise and displays the values. So this example is also from a G, right? So it has row values as well as scaling values. Every value need to be scaled. So it's element-wise operation. And you can also concentrate matrix, right? So if I have 2 matrices, I concentrated by row by using a function cat. Cat is a function, right? So it has certain rule of typing its argument. First, number specify which dimension you want to concentrate. 1 means you concentrate by row. 2 means concentrate by column. And the second and the third argument are the 2 matrices. Right? Just use cat, you'll concentrate in different way. And you can also concentrate by using the middle bracket. Right? So first, the matrix is 1 times 4 dimension, and second is 1 times 4. You use comma, and comma is just stay in the same line, right? You just stack 2 vector together by the same line. So it will be a 1 times 8 vector. If you use semicolon, you switch line, right? So then it will become 2 times 4 dimensional matrix. Please try this in the command window to get familiar with when to use middle bracket, comma, and semicolon. Right? So this you need to be very familiar with this usage to, in order to handle the matrix dimension well. Okay, any question for this one? Okay, if not, I assume you are now familiar with this matrix operation. So the key is that whenever you deal with matrix, keep in mind its dimension. So when you operate two matrix, know the dimension of this matrix to choose the correct operation. Okay, then here is what I actually told before. Then when you use size, then it automatically use the if you call ANS, it will automatically use the latest value of ANS. And you can also find elements in the matrix. Right? So if you type find ANS, it will find the matrix variable equal to some value. It will find all the elements that equal to this value. Right? So the only value here equal to 1 is this guy. It will go from the first column to the second. So the 1, 2, 3, the third element will be this value we want to find. If you find ANS without type anything, right, we just find the non-zero values. Non-zero values, which are all the values here except the first one, right? 2 to the 8 values, 2 to the 8 elements in this vector are non-zero. So now we have known how to deal with matrix. Before we get more complex, we want to introduce a code to print out something. Right? So we use fprintf. This one is a bit complex than display. If you remember display, display is just to show a variable. Fprintf is to show a sentence. It's a composed sentence. You can show a string and variable. So when you want to insert a variable, you use the percentage. Right? So also string use a single quote, 2 single quote. Within this quote is a string. And you use percentage d to replace this percentage d by a number, by an integer, and percentage s by the string, by a string. So I have a variable day, which is a number. So it will replace this percentage d, and the percentage s will be replaced by this string variable program. So if I fprintf this sentence, it will give today is day one of MATLAB. If you want to have day, you can add the string day here. Right. So this is a composed way of typing some sentence, which can be used to print out some result you want the code to do. So now it's a task here is example 5. You can open example 5, and there is a task to finish this fprintf sentence such that it can print out the row value, scaling value, and scaled value. Right? Just to revise this last line of code here in fprintf to print out the values. Oh, by the way, also in the early, there is also a task of concentrate the two matrices in a single row. Right? Concentrate the two scaling values in a single row vector. So two tasks for example 5. Please take 1 or 2 minutes to do this. This one is a little bit difficult, so take a bit more time. So if you want to have a break, we can have a 3 minutes break. Okay, any question for this task? Okay, if not, we briefly look at here. First, concentrate to vector, right? So it's we just told here it's just to have a middle bracket and a comma to concentrate the two vector in a single row. And now you have all the variables, you just need to print it. And as we just mentioned that if you want to replace a value, some data of numbers into this sentence, you should use the percentage %d, right? Percentage %d, then the first percentage %d will be replaced by this value. And difficult here is that you want to replace it by the seventh value of the row variable, the row value variables, right? So now I have the variable name row values. I use small bracket 7 to take its seventh value, and same for the scaling and scaled values. Right? So small bracket is to take some certain positions of the value from a vector or matrix. right? So small bracket to take the certain positions matrix. Let me explain here. If you see my screen, right? So what we have told now is middle bracket is to define matrix. Whenever you define a matrix, any matrix, you need to use the middle bracket, right? Define a matrix. And small bracket is used for function when you put the function's argument, right? Function's argument, and to call the matrix certain element, right? or vectors certain element, is to use small bracket. That's a usage of this two bracket. Right. So for example, this should be common. And for example, if I want to call the first row a second column vector element of this matrix, I should use small bracket. Right. So this is a small bracket. So if I have a vector here, as we see this example, if we have a vector, we want to call the seventh element of the vector, it should use small bracket 7. Right. And they also replace the second D by the second variable here, the third. So now you have a sentence print out 7th entry, and /n is to switch a row, right? So I have a note here I didn't mention. /n is to insert a new line, just switch a line for the string. /t is a tab. Right? /n is a change the row. And so you go to second row, 7th entry, row value replaced by this guy, 7th element, which is 5. And the scaling value, scaled value, just print out the result. I got a question. Could you repeat what the first in the cat function argument in the cat? Oh, in the cat function, if you use cat to concentrate the matrix, right? So cat first argument is which dimension you want cat the matrix, concentrate the matrix. The first one means you concentrate by the first dimension, which is the row. You concentrate two matrix by the row. If it's 2, then it's concentrated by its column, right? So actually, that's a very relevant question here. If you want to use cat to concentrate these two matrix, you should use cat 2, right? Because you want to concentrate in their column such that they become a single row vector. Right? So here you can use cat 1 small bracket, right? Because it's a called function. Cat small bracket 1. Then these two variables, this will achieve the same function, a same result of the middle bracket here. Any question? Okay, then we already know some basic operation, of manipulating matrix and displacing some result, right? So all these things are prepared for our later task of more complex task of doing to handling function and complex script. And before going to that, we will also introduce some sentence. And for sentence, we first introduce the relational operators, like less than or greater than. This is like relational operator to compare values, right? If you type 2 values, x greater y, it will give you answer. This answer is a logical output. If this relational operator matches, then it's 1, otherwise it's 0. Right? So this relational operator is useful for writing sentence. So now we introduce the first sentence. we have is if statement. So if statement is a statement that when some condition met, then some code will be executed, right? So if I have two numbers here, number 1, number 2. Number 1 is 0.5, number 2 is rand1. So rand is another function. It's a random number from 0 to 1, uniform distributed random number, right? 1 here, small bracket 1 is just a specified dimension. So it will give you 1 times 1 dimensional matrix with random number. So it's just a random number, right? 1 times 1 dimension. So then you compare these two values. When the first number is greater, it will display number 1 is bigger than max equal to number 1. You can run this, right? So then you see that this script is named by me as if, right? So I run this script if 3 times. The first 2 times doesn't show anything, right? So what happens is that this condition doesn't met. So if this condition doesn't met, it doesn't show anything. It just goes through the code and nothing was displayed, right? But the third time, the random number happens to be smaller than the first number. Then it shows the number 1 is greater, max is equal to 0.5. Right, so this is the if statement. You can make it more complete by having an else part. So means when the condition met, you run this part of code. Else, you run the other part. Right, so for comparing two numbers, if the first number is bigger, I show this one. Otherwise, I show the number is not bigger and I make the maximum number equal to the second one, right? So now if I run the code, each time I will get output, right? Because it's either the first case or the second case. So first case will be number 1 is bigger, then max is 0.5. Or the number, the bigger number is the second number, right? It's just a random number. This time it happens to be this guy, right? So that's by using if else statement, you can have a classification on the cases you can have. Then you can even add more complex classification, right? Else if first case is number 1 is bigger, second is number 1 is smaller, and the last one is they can be equal, right? So it's either bigger, smaller, or equal. So now you have the full classification on comparing two numbers, right? So this is a short code to compare any two numbers, to classify the cases of any comparing two numbers. And you can also have a nested if statement by having multiple if, right? So could you open the example 11? And delete the string in the fprintf such that this if else statement makes sense, right? So I just want to say that when the first number exp1 is greater than the second number more than 50, then I say it's much bigger. Otherwise, I think it's slightly bigger, right? So you just need to delete the string to make this if statement sound. I think this one is not difficult, right? So first is to make the first f printf much bigger, right? Second is slightly bigger. Right, so this is the result. And the second sentence is for loop, right? Before that, do you have any question about the if statement? All right, so if statement is very commonly used, right? So I would say every script I wrote, it will typically you have if statement, because you want to run some code with certain condition met, that typically happens, right? So you need to understand how to use if. And for loops is also very widely used, is to run a recursion, right? So when some condition, when some numbers goes through certain values, it will run the loop several times. Right. So here for a equal to 10 to 20. Right. So 10 to 20, remember the way when we define the vector, right? 10 to 20 is from 10 to 20 with step length 1. So it's 11 numbers, right? From 10 to 20. So this loop will be run by 11 times. So each time it will print this string value of a, replace the percentage d by a, and slash n is switch line. Right, so value of a, so you see result here, value of a 10 to 20, run 11 times. That's how you define f. And by the way, here for, whenever you use for loop, it should be combined with the end, right? So this is a whole part of for loop. For end, for with the values you want to go through, right? So this loop will go through, and end. Up to end, it will be run one time and then repeat this. So for here, now if you open the example 12, right? So please adjust to print the values from 0 to 15, right? So adjust this for loop to print the value from 0 to 50 instead of 10 to 20. Right? In your example 12, please try this. I think this one is easy. You just need to change the values here from 0 to 50. Okay, then we basically manage everything we can do a complex task. This will be assigned to your homework, but let me explain it. So what we have learned is matrix, right? So you know how to input matrix and do the operation, and you know how to print out something, print out the result in a sentence. And you also know how to use for loop and if statement, right? So that's our day one. So now, after all of this we have learned, we want to do a bit difficult task. So this task is I give you a list of gene names. So here we will introduce, actually tomorrow, is the cell structure. Right? Cell structure is we'll introduce more tomorrow, but here just briefly, cell structure is a composition of many different element, right? This element here is string, right? You see the code here. So each element is a string. It's a gene name, like IL1A is a gene name, and FKBI is another gene name. So these are several gene names. And when we define cell, we use the big bracket, right? And once we use big bracket, everything, the shape of the data, the dimension of the data is the same as the matrix, right? So by using the comma here, then it will give you one row of the data, right? And here you have 7 element, so it will be 1 times 7 dimensional cell by having this big bracket, sorry. So here is all the gene name here, right? So by defined in a cell structure called exp1 gene. And the second variable is their gene expression, right? I give it a name as exp1 result. So it's a vector, right? So by have middle bracket, I use a vector. It's a collection of numbers. So it's 1 times 7 dimensional vector with the values, with these 7 values. And I also have a specified threshold value, which I will use later. So now the task is I want to go through this gene list, go through just like I will check the gene, first gene, second, and go through. And then I will also go through their corresponding expression value given this vector, right? Just go through it. And when I go through it, I check whether this gene has expression over than the threshold. I check the first gene, IL1A, its expression is 4, and I check whether this expression is over than 20. If it is over than 20, then I will print out this gene. Right, so that's the task here. So I have some pseudocode writing here in the comment, right? By using for loop. If you have, if I have a gene list and the gene expression, I want to use for loop to go through this gene list. If when the gene expression is over than this threshold here, I will print out something. Right? So when it's over that threshold, I will use if statement. Right? So I will use for loop and the if statement, and I also print out those gene over that threshold. Right. So the ideal output would be when I run this example 13 code, right? You have example 13, you can open it. After you finish writing the code, ideal output is when I run it, it will show that all the gene whose expression is over 20. Show their name and show their expression, right? For example, the second gene, NFKBIA, has the expression 56, which is over 20. It will show here. And then show all the gene, their name and expression, once their expression is over 20. Right, so that's the task here. We want to use this for and if statement to realize this task. And the hint is that whenever you call the ith element in your cell, you use big bracket. And when you call the ith element in your vector, you use small bracket. Right. So cell structure, we haven't introduced a lot. But here, just remember this usage. You use big bracket for cell to call its ith element, and small bracket of a vector to call its ith element for vector. Right. So this one we have introduced for vector. So this is the end of this class. This is a bit difficult task. I think once if you really know you can finish this task, and you basically learned everything in day one. Right? So please take take some time after this, maybe 10 minutes or 20 minutes, just try and see if you get a good result. Okay, so that's basically day one. So if you have questions, you can stay here and ask. And if not, you can feel free to go. Any question about this homework, you can also ask. What's anything unclear about this problem? So I have one question. How is the MATLAB for NGS? So you mean use MATLAB to do NGS? Yeah, and next generation. Yeah. This workshop will not touch that. This is I think adding NGS will be challenging, will be out of the scope of this workshop, because this workshop is an introduction to MATLAB, so we will not cover NGS. And the second thing is NGS for most of the time, I think it's done by R or Python more, right? So Collaborator has another workshop of handling NGS. I think it's done by R. In MATLAB, I think there should be some package of doing NGS, but I don't think it's the most popular software to do NGS. So we won't handle NGS in this workshop. Bioinformatics package. Yeah, I mean, there should be some package doing some and next generation sequences. There are also packages doing single cell RNA by MATLAB. There are packages, but my point is that it's not the most popular software in doing this sequence analyze. So it's the most popular package should be in R or Python. And for this workshop, we will not go to those more advanced bioinformatics package. Right. So this workshop is more introduction on the code of basic code of MATLAB.